Another day of computer science lecture. Today was on list slicing, nested lists, and what was that first thing? Enumerate, iterating over a list. So one thing I did learn, a little note, is that the sum function cannot actually, it will return an error, a runtime error, if you have a list with any strings in it. It's got to just be numerical based data, I believe, entries. Anything else? For loops, nested for loops, enumerate, slicing. Yeah, let's see. Lists, sequence type functions, right? I think sequence type functions are basically sequence type functions? Oh, what the hell? I thought we were sequence type. Oh, probably that for sequence type data, the sequence type functions can work on all of them, I would say. That's probably what that is. Such as length, such as sum. Some won't, but length will work for all of them. Like lists, dictionaries, tuples, strings, length will work for all those. Dictionaries, I think. Iterating over a list, enumerate, list nesting, list slicing. Can't use sum if list contains strings. So for 2D basic lists in Python, they are row major, meaning you say row first, then column. This is the same with matrices, but apparently that's not common for normal people, where you use like Excel and stuff. It's column row apparently, so column major is probably what it's called, but I'm very used to row column with all the matrix stuff I've been doing. So that's it for now. Talk to you later today. Welcome back to computer science. Yesterday we did list slicing. Right, produces a new list. You got the stride if you want that extra argument. List indexing, out of range, index error. What was the other thing? List slicing. What was the unit before that? Iterating over a list, and then right. We also talked about multi-dimensional, basically data structures using lists, nested lists. That's what it was. Lists within lists. You can do as many of those. You can nest as many as you want. There's no limit. All right. List slicing. Slice notation start end. If the end is less than the start value, you'll get an empty string returned. List nesting. Iterating over multi-dimensional list, nested for loops, and enumerate. Multi-dimensional data structures. Data table, matrix, grid, conceptually. All right, that's it for recall. I'm gonna jump into the next lecture now. Apparently, we have the biggest program to write in the whole semester this week. So yeah, I'm gonna try to get ahead of things this week, considering we're already starting, not behind, but not ahead. So I'm gonna jump and be back in a bit. All right, so this next lecture is on, again, list slicing and nested lists. So more. This first unit is on iterating over a list, again, I believe. And a common error in iterating over a list is modifying or changing the list size, that is adding or deleting elements while iterating over the list. That causes problems 99.9% of the time. Unless you like have some really weird use case that I've never heard of yet. I don't know much about it yet, so it's possible, but that's a common source of errors. Yeah. Simple fix is to iterate over a copy of the list. Okay. So lecture 24 is list nesting and slicing. This first unit's on loops modifying lists. So some common errors while iterating over a list stem from changing the list size, that is adding or removing elements from the list while iterating over it. Simple fix, iterate over a copy of the list. So that's it for now. I'll be back later to do another session. Talk to you then. Welcome back to some more computer science. Earlier, we were doing more iterating over a list with loops. I'm going to jump back in, continue learning, and then I'll be back to recall what I learned a little bit. All right, finished up that unit on iterating over a list. The next unit, what is this on? List comprehensions. List comprehensions is basically like a shorthand way or a shorter way, more efficient way to write for loops that iterate over a list if you are modifying every element of the list the same way. And the way it's a construct in Python, and the format is basically it creates a new list, first of all. So say new list, new underscore list gets, and then you have brackets around the list comprehension. You have an expression. This is going to be how you modify or change the elements for loop variable in list. That's it, and then bracket. And that creates a new list, yes. And actually it's not just for list, it will actually iterate over any iterable object, but it always outputs a list. And this is preferable to for loops, for iterating over a list for with the same modification, because it's less code and it's more efficient. The interpreter can interpret it quicker, faster, more efficiently. So list comprehension. Construct in Python iterates over a list or actually any iterable object, modifies each element in the same specified way, and returns a new list of the modified elements. New list equals bracket expression for a loop variable name in iterable bracket. Preferable because they are one, less code, and two, faster, more efficient execution by the interpreter. For loop for loop modifies the list, whereas the list comprehension actually creates a new list. All right, that's it for today. We're looking good for being back on track. So for this week. So talk to you tomorrow. See ya.